And how can we understand it?
Aha! I have an idea.
I have an idea.
Really? What is it?
That's better.
Alex, can I borrow it?
Yes, sure.
Let's watch the video tutorial on YouTube. That's right.
What's up, guys? Welcome to our YouTube channel. This is Math
Linguistic!
Having problem in solving basic calculus?
No problem!
So don't forget to like,
Share and subscribe!
our video. So,
Without further ado,
let's start. So hi guys, our topic for today is all about derivatives using the limit process. So our given is f of x is equals to 2x squared minus 16x plus 35. So using the formula of the limit process, f prime of x is equals to f quantity of x plus h minus f of x over h as h approaches to 0. So the first thing you will do is you need to substitute all the x into x plus h. So we come up with this equation. 2 quantity of x plus h squared minus 16 quantity of x plus h plus 35 minus the given quantity of 2x squared minus 16 plus 35 over h. So the next thing you will do is you need to distribute each factor. So we come up with this equation. 2x squared plus 4xh plus 2h squared minus 16 minus 16h plus 35 minus the given over h. So the next thing is you need to cancel out all the like terms. So we come up with this equation. 4xh plus 2h squared minus 16h over h. The next thing you will do is you need to factor out each term, so we come up with this equation. And after that, you need to replace all the h into 0, so we come up with this equation. And lastly, my final answer will be the f prime of x is equals to 4x minus 16. So the second equation will be f of x is equals to 3x plus 6x. So using the formula of the limit process, f prime of x is equals to f quantity of x plus h minus f of x over h. So you need to substitute all the x into x plus h, so we come up with this equation. 3 quantity of x plus h plus 6 quantity of x plus h minus the given 3x plus 6x over h as h approaches to 0. The next thing you will do is you need to distribute each factor, so we come up with this equation. 3x plus 36h plus 3h plus 6x, so on and so forth, minus the given over h. And the next thing you will do, you need to cancel out all the same terms. So the next thing you will do is you need to factor out each term. So we come up with this equation, and you need to substitute all the h into 0. So my final answer will be f prime of x is equals to 3x plus 6x plus 6x.
Differentiation rules. First rule, sum rule. If f of x equals h of x plus g of x, then f prime of x equals h prime of x plus g prime of x. So, first example, x squared plus 12x. So, the derivative of the example 1 is 2x plus 12. Why do we get 2x plus 12? So, the x squared, the 2 here, we multiply the imaginary one to x has an imaginary one, so we multiply the 2 and 1, so 2x plus 12. So number 2, 2x cubed plus 9, so the derivative is 30x squared. So number 3, 3x to the raised to the power of 4 plus 8x cubed plus 12x. The derivative of the example number 3 is 12x cubed plus 24 squared plus 12.
So the next topic is difference rule. If f of x is equal to h of x minus g of x, then f prime of x is equal to h prime of x minus g prime of x. So example number 1, x cubed minus 4x raised to the power of 4 is equal to 3x squared minus 16x cubed. So how do we get this answer? So the exponent 3 times to the imaginary 1, so it will be 3. Then the exponent minus 1, so 3x squared. Then minus 4, the exponent of 4 and the 4. So 4 times 4 equals 16, and the exponent minus 1, it would be cubed. So 3x squared minus 16x cubed. So let's go with number 2. 2x raised to the power of 4 minus 5x squared is equal to 8x cubed minus 10x. So the same procedure with the number 1. And then let's go number 3. 3x cubed minus 8x is equal to 9x squared minus 8. So just the same with the procedure number 1.
The next topic is constant multiple. If C is a constant, then d over dx is equal to d over dx of f of x. Number 1, negative x raised to the power of 4. The answer is negative 4x cubed. How do we get this answer? F negative 4x cubed is 4 times imaginary 1 is equal to 4, negative 4. Then 4 minus 1, that's why it's cubed. Number 2, 4x cubed is equal to 12x squared. The same to the procedure of number 1. Then number 3, 12x squared is equal to 24x. The same to number 1.
So the next rule is the constant rule. So the derivative of a constant is 0. So and we have the 3 example of the constant rule. So the given number 1 is 6 equals to 0 derivative, and 69 is the derivative equals to 0. 34 is the derivative equals to 0.
So the next rule is power rule. If a function is defined by f of x equals x of n, where n is any given n, then the derivative of f of x is given by f prime of x equals nx to the raised of n minus 1. So here are the examples. So 7x raised to the power of 5 equals 35x raised to the power of 4. So the constant multiply the exponent. So the result is 35x, then minus 1 the exponent, so 4. Then the second example, 10x squared plus 6x raised to the power of 5. So the answer is 20x plus 30x raised to the power of 4. Multiply the constant and the exponent, then 20x, then minus 1 the exponent, plus the same process, multiply the constant and exponent, then 30x raised to the power of 4. A squared minus 23x cubed equals 2x minus 69x squared. So always follow the process and don't forget the put the signs, and thank you.
So hi guys, the next topic is all about the chain rule. This rule states that the derivatives of the outside leaving the inside alone finds the derivatives of the inside function. So the first example is g of x is equals to quantity of 5x plus 3 raised to the power of 4. The first step you need to do is you need to bring down the exponent 4, then copy the quantity of 5x plus 3, then minus the exponent with 1, then put the derivative of x, so 5. Then the next step, you need to multiply the 4 and the 5, so equals to 20, then copy the 5x plus 3 raised to the power of 3. So the next example is f of x is equals to 4x plus 14 raised to the power of 50. So like the first example, you need to bring down the exponent 50, then copy the quantity of 4x plus 14 raised to the power of 49 because you minus it by 1, then the derivative of 4, the x. So the last is you need to multiply the 50 by 4, so equals to 200, then copy the quantity of 4x plus 14 raised to the power of 49. So the last example is h of x is equals to 10x plus 8 raised to the power of 150. So like the examples given, you need to bring down the 150 because that is the exponent, then copy the quantity of 10x plus 8 raised to the power of 149. Then you need to get the derivative of x, then the x, you need to multiply the 150 by 10, then so equals to 1,500, then copy the quantity of 10x plus 8 raised to the power of 149.
So, we have our next topic. We have the derivatives of trigonometric function. So, the first example is f of x is equals to cosecant to the power of 4x cotangent x. So we have to follow the formula. We have u dv plus v du. First step is we have to identify the derivative of u. We have negative 4 cosecant to the power 4x cotangent x. And the derivative of v, we have negative cosecant squared x. And then we are going to follow this, the formula. We have u cosecant to the power 4x times the derivative of v. We have negative cosecant squared x plus the v cotangent x times the derivative of the u. We have negative 4 cosecant to the power 4x cotangent x. After that, we have to add the like terms. So we have negative cosecant 6 to the power of 6x, negative 4 cosecant to the power of 4x, and cotangent squared x. That is now the answer. So for our second example, we have 1 minus cosine squared x over 1 minus cosine x. So since it is fraction, we are going to use the formula v du minus u dv over v squared. So this is our u and this is our v. After that, we are going to find the derivative of u and v. So the derivative of u is this one and the derivative of v is this one. After that, we are going to follow this formula. So we have v 1 minus cosine x and the derivative of the u. And then minus the u which is sine squared x. And if you wonder why this is sine squared x, it is because the sine squared x is the trigonometric identity of 1 minus cosine squared x. So that is why. After that, we are going to copy the derivative of v. We have sine x over v squared. So we have 1 minus cosine x squared. After that, we are going to multiply these terms and we come up with this equation. And then we are going to minus the like terms. After that, we have now the answer. So we have sine 2x minus 2 sine x cosine squared x minus sine cube x over 1 minus 2 cosine x plus cosine squared x. So for our last example, we have f of x is equals to sine x cotangent x. So we are going to use the formula u dv plus v du. After that, we are going to find the derivative of u and v. So we have the derivative of u cosine x and the derivative of v cosecant squared x. After that, we are going to follow this formula. So we have the u, the sine x times negative cosecant squared x plus cotangent x times cosine x. After that, we are going to change the identities that has trigonometric identities. So we have this and this. After that, we are going to multiply these two terms. This is now the answer. After that, we are going to add these two terms and we come up with this equation. And then, we are going to find the trigonometric identities of cosecant squared minus 1. So it is sine squared x divided by sine x. So the answer is negative sine x.
Now, we have the application of derivatives for optimization. For our problem, we have a piece of cardboard that is 50 by 20 centimeters and we are going to cut out the corners and fold up the rides to form a box. Determine the height of the box that will give a maximum volume. We have V of h is equals to h times the quantity of 50 minus 2h times the quantity of 20 minus 2h is equals to 4h cubed minus 140h squared plus 1000h. Then we have the V prime of h is equals to 12h squared is equals to 280h plus 1000. We have V of 0 is equals to 0. We have the V of 4.4018 is equals to 2030.34. So we have the h is equals to 4.4018. We have h is equals to 35 plus minus 5 times the
Application of derivatives, related rates. So for this problem, we need to use or apply what we have learned from the previous lessons for this problem. First, we have the first problem. A 15-foot ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 feet per second. How fast is the top of the ladder moving up the wall 12 seconds after we start pushing? First, we need to visualize our problem. We have a right triangle and then we need to assign values onto it. We have x as the distance between the wall and the ladder and y as the height of the ladder. We have the hypotenuse 15 as the length of the ladder, and we have x to the power of t as negative 1/4. Next, we need to find x. So x is equals to 10 minus 1/4 times 12 is equals to 7. So x is equals to 7. Then we have x squared plus y squared equals 15 squared equals to 225. Then to find y, we will use the Pythagorean theorem, which is stated a few moments ago. So we have y is equals to the square root of 225 minus x squared is equals to the square root of 225 minus 49. So y is equals to the square root of 176. Using implicit derivation on this equation would give us 2x times x prime plus 2y times y prime is equals to 0. Integrating the values we got a few moments ago will give us 2 times 7 times negative 1/4 plus 2 times the square root of 176 times y is equals to 0. Will give us y prime is equals to 7 over 4 over the square root of 176 is equals to 7 over 4 times the square root of 176 is equals to 0.1319 feet per second. So application of derivatives, related rates, problem number 2. Suppose that air is being pumped on a spherical balloon at a rate of 5 cm³ per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeters. First, we need to find the values in order to solve our problem. We have v prime of t is equals to 5 in response of volume, and we have r prime of t is equals to question mark as it is the radius. Since we know that the diameter is twice the radius, all we need to do is to divide the diameter into 2. So we will have our radius. That gives us r prime of t is equals to d over 2 is equals to 10 centimeters. Using the formula v of t is equals to 4 over 3 pi times r of t cube, we will integrate our values that we found just now into that formula, which would then give us 5 is equals to 4 pi times 10 squared times r prime. So r prime is equals to 1 over 80 pi.